inequalities in one variable, we're going to graph inequalities in two variables. We graph these just much like we graph linear equations, where there's an equal sign in here. So let's just pretend that that's what we're starting with. Let's pretend we're starting with y equals 2x minus 1. So we know that the number in front of x is our slope, and the number that's being added or subtracted from the x term is our y-intercept. So with this equation, our y-intercept is at -1 and our slope is a +2, or rise 2, run 1. So I'm going to come down here to -1 and I'm going to put a dot there. And if that is not dark enough to see, let's just make it a little bit bigger. Okay, so there's my y-intercept at -1. And to get to my next point, I need to rise 2. So there's 1. I'll rise 2, and I'll run to the right 1. And I'll put another dot there. And I'll just keep doing that. Rise 2 and run to the right 1. Okay? Now normally I would take these 3 points and I would connect them with a solid line, and only those points on that line would be the solution. But because our original inequality, which was way up here, has a less than symbol in it, that really means that the solutions right on the line do not even work. So to indicate that, what we need to use is a dash line. Kind of like on the last ones in one variable. Sorry for the not so straight line here. But the last equations where there was just one variable, when our symbol did not have a line under it, when it wasn't included or equal to, we used an open circle. This is equivalent of the open circle here. So when it's a less than or just a greater than, you'll use a dashed line to draw your line. Now, these are not even, the numbers, the ordered pairs on this line are not even solutions to the inequality. So where are the solutions? Well, according to this inequality, the solutions will be less than that line or smaller than that line. Sometimes that's a little confusing to people. So we're going to take a look at a specific point that's on one side of this dashed line. And I don't care which side you use, I don't care which point you use. I like to go for easy points to use. So I'm going to pick 0, 0. And I'm just going to test 0, 0. This is our test. We want to decide, where do the answers to this inequality really lie? Do they lie on this side of the line where 0, 0 is, or do they lie on the other side? Well, when I say test 0, 0, I want to see what happens when I plug 0, 0 into the original inequality. So, is 0 less than 2 times 0 minus 1? Well, let's see. 2 times 0 is 0. 0 minus 1 is -1. Is 0 less than -1? Is 0 a smaller number than -1? No, it is not. So because 0, 0 is on this side of the inequality where I did my writing, 0, 0 doesn't work. I don't want to shade 0, 0. Oh, this is going to be a problem on here. Oh, not so bad. I want to come shade on the other side. Now, if I were to pick a point on that side, which I didn't do, let me just show you. If I picked the point and tried 2, 0 instead of 0, 0, I should have saved a little space here, but let's see if we got room down here. 2, 0. Say I tested that instead. So y is the second number. Is 0 less than 2 times 2 minus 1? Well, to save space, 2 times 2 is 4. 4 minus 1 is 3. Is 0 less than 3? Yes, it is. That's why the point 2, 0 over here on this side of the inequality has been shaded. And of course, you would still put arrows on the ends of this line to show that that line keeps going in both directions forever. The dashed line shows the points on this line do not work in the original inequality. And the shading shows, hey, there's a bunch of numbers over here, a bunch of ordered pairs that satisfy this inequality. They make it true. One of the examples is 2, 0, but that's only one. Okay, let's move to the next inequality. And again, we have a y-intercept of positive 4. We have a slope of negative 3 over 1. This time the symbol is a greater than, and it does have the line underneath it. So that means that the points on the line do work in the inequality. And you could pick a point on the line and test it, just like I tested points that weren't on the line. So anytime we have a less than or equal to or a greater than or equal to, we're not going to put a bunch of closed circles around here. We're just going to use a solid line to show that. So this problem here is no different than what we graphed when we graph lines, other than we're going to have some shading. So these kinds of graphs will include shading. When we graph just linear equations with the equal signs, there was no shading. These will include shading. Okay, so I need to find out where I'm going to start. And I'm just going to make 4 tick marks here. And I'm going to put a y-intercept up there at positive 4. That's my y-intercept. Now to get to other points on my line, I need to have a slope of negative 3, which means for my rise, I'm going to go down 3. 1, 2, 3, and I'm going to go to the right 1. And I'm going to put a dot there. And because I like to have 3 points, I'm going to go down 1, 2, 3, right 1, and put a dot there. When you do yours, make sure you use a piece of graph paper so that you can do nice equal intervals, nice points. Make sure you have nice lines. You can use a straight edge to connect them. On Moodle, you're not going to be drawing lines. You're going to be matching graphs to equations or inequalities. So because it says greater than or equal to, the equal to part underneath tells me I want to make a solid line. Yours will be straighter. Use a straight edge. Now, because I have to include shading, I need to know, should I be shading, let's say on the left side of this or on the right side of it? Well, one of the surest ways to decide is to try a point. And again, I like to try 0, 0. You cannot always try 0, 0. If 0, 0 happens to lie right on your line, you can't test it. You have to test something else. Like over here, I tested 2, 0, just to show you. So I'm going to plug 0, 0 in there. Is 0 greater than or equal to the answer that I get when I do negative 3 times 0 plus 4? Well, and remember, I'm asking myself. That's why I put that question mark there. Negative 3 times 0 is 0. 0 plus 4 is 4. Is 0 greater than or equal to 4? No, it's not. So 0, 0's right here. I know I don't have a dot there. I don't want to shade 0, 0 because 0, 0 did not work. So I'm going to shade on the other side of the line. And you don't have to get crazy with your shading. Just enough for the person who's reading your graph to see what side of the line you shaded on, and that's plenty. You could go the whole section over here, but there's no need to do that. Again, as long as the person who's reading can tell what side is shaded, you don't need to go overboard. Okay, and then the last one, just another example. This time y is not alone, so I have to make some changes, just like we practiced before. I'm going to change the color here. I'm going to add 2x to both sides because I want to get y alone. It's been a while, so I thought this would be a good time to review this. Y is less than 2x plus 3. My y-intercept is a positive 3, so I'm going to come up here 3 points. Make a nice heavy mark so that hopefully we can see it. Yep. Okay, and my slope is to rise 2 and run 1. So I'm going to put a dot there. And since I've kind of run out of space, instead of going up to right 1, I'm going to go down to 1, 2, and left 1 and try to get those in a nice straight line. Okay, this inequality is just a less than, so I don't want to draw a solid line. To show just less than, I draw a dashed line. Arrows, arrows. I forgot arrows over here. Okay. Now the only thing is, what side should I shade on? Well, let's try 0, 0. I want a little smaller tip. So I'm going to try 0, 0. And when I try it, I'm going to go back to the original. Negative 2 times 0 plus 0. Is that answer smaller than a positive 3? Let's see, negative 2 times 0 is 0. 0 plus 0 is 0. Is 0 smaller than 3? Well, sure it is. 0, 0 lies right here. So because it worked this time, finally, for the first time, it worked, I want to shade on the side of the line where 0, 0 lies. So that would be over here. Now, I don't know if you noticed a pattern or not. This one was less than. I shaded below the line. This one was a greater than symbol. It's above the line. You might say, well, that's to the right. Yeah, but the numbers on that side of the line are getting bigger in both directions, so it's above it, in my opinion. This one said less than, and the shading was below, rather than being up above over here. But again, if you're not sure and can't tell which side's above, which side's below, this one's hard maybe to tell which one's above and which one's below, then try a point. Doesn't have to be 0, 0, but that's usually the one with the easiest math, as long as the line that you graphed is not going through 0, 0.